morning all, I am Dr. Padma, Assistant Professor, Department of Mathematics from Burdhamon College of Engineering. Today we will discuss Green's theorem in plane from vector integral calculus. If capital R is a closed region in xy plane bounded by a simple closed curve C, and if m of x comma y and n of x comma y are continuous functions in x and y having continuous derivatives in R, then integral C, closed integral C m dx plus n dy equal to double integral R dou n by dou x minus dou m by dou y into dx dy, where C is traversed in a positive direction. Green's theorem is actually used to integrate the derivatives, in particular plane. For this, Green's theorem is used. We will solve two problems in this model. Question is, apply Green's theorem for closed integral C xy plus y square into dx plus x square dy, where C is bounded by y equal to x and y equal to x square. Y equal to x is a straight line and y equal to x square is a parabola. Before solving the problem, let us see the graph of this. So this is x axis and this is y axis. Y equal to x square. Y equal to x square, it is a parabola. So it will come like this. So this is y equal to x square. So here 0 comma 0. And next y equal to x. So y equal to x is a straight line from the origin. So here is the intersecting point. This is y equal to x. So 1 comma 1 is the intersecting point. Now this is the graph. From this graph we find the limit. So already for y they have given x square. Y equal to x square to y equal to x. And for limits for x are, x varies from 0 to 1. Now from Green's theorem. So from Green's theorem, the definition of Green's theorem is closed integral C m dx plus n dy equal to double integral R dou n by dou x minus dou m by dou y into dx dy. This is the formula for Green's theorem in plane. So actually in the question what they have given this single integration. So integral function of xy dx plus x square dy. So m dx plus n dy they have given. So we will solve it by using the double integration. So according to the question, m equal to xy plus y square and n equal to x square. Now what we have to do, we have to differentiate m with respect to y and we have to differentiate n with respect to x. So dou m by dou y, dou m by dou y. So with respect to y means y will become 1, x we will get. Next y square will become 2y. Next dou n by dou x. So with respect to x means x square will become 2x. So we got dou m by dou y and dou n by dou x, and the limits are also from that graph. So x varies from 0 to 1 and y varies from x square to x. So now we will substitute this one. The question whatever they have given, integral C xy square. Now the answer is x equal to 0 to 1, y equal to x square to x. Now what is there? Dou n by dou x. What is dou n by dou x? 2x minus dou m by dou y. Dou m by dou y is x minus 2y we get dx dy. So if you simplify this, x equal to 0 to 1, y equal to x square to x. So we get here x minus 2y. As we are integrating, first y is there, we integrate with respect to y. After that we integrate with respect to x. So if you integrate with respect to, we will integrate with respect to y. So x equal to 0 to 1, if you integrate with respect to y, you will get x y minus 2y will become y square by 2. 2 will get cancelled and the limits are x square to x. So if you substitute the upper limit, so which is equal to x equal to 0 to 1. So if you substitute the upper limit in the y place, we get here x into x square minus, here also if you substitute, it will become x square. So this is the upper limit minus of lower limit. Lower limit is x square. So if you substitute x square in the y place, x into x square, we get x cube minus is there. Next x square whole square, we get x to the power of 4. So x to the power of 4 into dx. After the simplification, this will get cancelled. Now x equal to 0 to 1 minus x cube plus x to the power of 4 into dx. Now we have to integrate with respect to x. So if you integrate, you are going to get x to the power of 4 by 4, and x to the power of 4 will become x to the power of 5 by 5. Substitute the limits. So what are the limits? 0 to 1 are the limits. So 0 to 1. So upper limit is 1 and the lower limit is 0. So we have to substitute the limit in the place of x. So 1 minus 1 by 4 plus 1 by 5. Lower limit it is 0 only. So if you simplify, you are going to get the answer 1 by minus 1 by 20. This is the first problem. We will see second problem also. Coming to the second problem, use Green's theorem to evaluate. So here also single integration they have given. So integral c 3x square minus 8y square into dx plus 4y minus 6xy into dy, where c is the region bounded by, so what they have the reason given, the reason x equal to 0, y equal to 0 and x plus y equal to 1. So before going to solve the problem, let us draw the graph for this also. So x axis, y axis, x plus y equal to 1 means we get the limits 1 comma 0 and 0 comma 1. So this is 0 and here you take means, so we get like this, x plus y equal to 1. So 1 comma 0, this is 0 comma 1 and this is 0 comma 0. Okay, so clearly from the graph, the limits x varies from 0 to 1 and y varies from, already the lower limit they have given 0, and from this y equal to 1 minus x. Okay, now we have to apply Green's theorem to solve this problem. So according to the definition of Green's theorem, closed integral c m dx plus n dy equal to double integral r dou n by dou x minus dou m by dou y into dx dy. So from the given question, m equal to 3x square minus 8y square, n equal to 4y minus 6xy. Now what we have to do, we have to differentiate m with respect to y and n with respect to x. So dou m by dou y with respect to y means this will become 0 and y square will become 2y means minus 16y. Next dou n by dou x. So with respect to x means here x is not there, so 0, and here x will become 1. Answer is minus 6y. Now we substitute this one. So by Green's theorem. So closed integral c m dx plus n dy equal to double integral. So already from the graph it is clear that x varies from 0 to 1 and y varies from 0 to 1 minus x. Y varies from 0 to 1 minus x. So x equal to 0 to 1, x varies from, y varies from 0 to 1 minus x. Next dou n by dou x. What is dou n by dou x? Minus 6y minus dou m by dou y is minus 16y. So minus into minus plus dx dy. So we get here 10, you can write outside. So x equal to 0 to 1. Now you have to integrate first with respect to y. So with respect to y means inside what will be left? 0, 1 minus x, y dy dx. Now we have to integrate first with respect to y. X equal to 0 to 1. Integral y will become y square by 2. Limits are 0 to 1 minus x dx. So 2 also you can write outside, so it will become 5. X equal to 0 to 1. If you substitute the upper limit, it will be 1 minus x whole square, and lower limit is already 0. So 0 we get dx. Now we have to do integration with respect to x. So integral 1 minus x whole square. So integral 1 minus x whole square, after doing the integration, will become 1 minus x whole cube by minus 3. Now substitute the limits. The limits are 0 to 1. So if you substitute the upper limit, minus 5 into 1, upper limit is 1 by minus 3 whole cube minus 1 minus 0 whole cube by minus 3. So it will become 0 starting one, and this one minus minus plus, we get 1 by 3. So finally the answer is 5 by 3. So this is the second problem in Green's theorem. So by using this Green's theorem, we can easily solve the integration in a particular region. This is about the Green's theorem. Thank you.